DirectX 12, which is DX12. It enables developers to add amazing graphics effects to Microsoft Windows-based PC games. GeForce graphics card deliver advanced DX12 features. Microsoft updated API bundles which first rolled out with GeForce RTX in 2018. And these features include DXR, DirectX RayTracing, mesh shading, VRS and sampler feedback. Even there are some additional graphics features supported like volume tiled resources, conservative raster, raster order views, tiled resources, typed UAV access, bindless textures, and the last, asynchronous compute. But to understand this in very simple form, now the games will be beautiful and more towards realism. It means we will enjoy playing more and more games. The heart of DX12 is ray tracing. Let me give you a short brief onto that if you are not aware of it. Mirroring how light actually behaves in reality, improved shadows, accurate GI, which is global illumination, and hyper immersive reflections are now possible. Ray tracing introduces some new technologies to the graphics pipeline, such as BVH. It stands for Bounding Volume Hierarchy Setup. Actually, this is an acceleration structure or data structure that makes possible to do high performance ray tracing into real time. And the second is ray triangle intersection. As the name sound, exactly it works the same. You shoot a ray into a scene, you decide whether or not to intersect with triangles, and now what would you like to do with it? Does it reflect or does it terminate? Is it blocked or occluded? And lets you decide things like reflections or shadows. Ray tracing image looks like grain image, but denoising where it starts the job. Actually, the path tracing plus turing plus artificial intelligence made it possible to polish the grainy image to make it a perfect final picture. The same thing with AO. It only hits the BVH part and enhances the depth of the environment with less calculation. Ray tracing reflections solves for all of that by tracing rays from the surface globally into the scene to compute the proper result on that pixel. Let me show you the battlefield clever technique to resolve reflections. They trace more rays which are reflective and less which are not. Actually, they track the area where they need more reflection. The best example of GI is the game Metro. They implemented a technique, one ray per pixel for the GI. It takes less time and produce good quality result. It is kind of natural lighting behavior. And if we talk about mesh shading is a programming model for geometry. It is very helpful for developers. Now developers can create highly detailed world while not overloading the CPU, which can bottleneck the GPU. If you have seen the asteroid demo of NVIDIA, mesh shader dynamically adjusts the LODs of countless items. LOD stands for level of details. They have done trillions of triangles workload has been reduced to millions of triangles in real time. It helps to gain FPS with dense meshes and gives you more better quality, the realism. If we talk about VRS, which is variable rate shading, it gives developers more control on the amount of detail. Shading on that part which is beneficial and relieve the effort on less prominent part of the scene. VRS can also be used in virtual reality games for foveated rendering, drawing more detail where your eyes are looking and less detail in the periphery where your eyes are not focused. Because as you know, where we focus we need more detail. Let me give you an example. There is a fast moving car in a scene. Now car needs to be more focused rather than the environment. So pixels of car need to be rendered more quickly as comparison to scene. Finally, let me talk about the sampler feedback. Now game engines can more efficiently shade objects that don't change from frame to frame and reuse the color of the object as calculated in previous frame. So GPU can pump out more frames. It also improves texture streaming. Developers can stream high resolution textures into their large open worlds to avoid stuttering. At the end, if we compare between Pascal and Turing cards, Pascal cards are not made for this. But due to DXR, as I told you in 2018, they released this technology. Due to DXR, Pascal holders do even get a taste of how it looks. Just the taste. These are the statistics from the game Metro. The first one is 1080 Ti running DXR software, ray tracing. The long gray bar that you see horizontally, RayTracing workload being run on the SM. SM stands for streaming and multiprocessor. It is 80% slower than Turing RTX. Why? Because Turing with no RT core can calculate floating point and the integer at the same time. But RT core plus DLSS. DLSS is deep learning super sampling, which needs AI, artificial intelligence. It calculates billions of rays per second and spends 1/10 of the time ray tracing compared to Pascal. So it is a combination of RT cores and tensor cores. Hopefully you enjoyed the brief overview of the API of DX12 with the knowledge of TXR, mesh shading, VRS and sampler feedback. If you love the work, do subscribe the channel. Thank you.